Hello. Right, this is just a little extra one for this lesson. Um, right, this is the quadratic formula, and this is when you cannot factorize. When you cannot factorize, you can use this. So if we have 3x squared plus 7x minus 1 equals 0, we've got to solve this. You see the factors of 1 are just 1 and 1, and they don't add up to 7. Or do they? 1 times 3 is 3. 1 times 1 is, it's just not going to work. Yeah, there's no way that you can do this and put 3x and x, that's a 3x squared, that's good. Now the only things you can do there and there, one has got to be minus and one has got to be plus. So you can have plus 3x and minus 1 is 2. So it's not going to work. So you have to use something called the quadratic formula. Let's wipe that out. So the quadratic formula is this, and it's always printed in your formula sheet for the that you get with your exam. So it's x is equal to minus b plus or minus the square root b squared minus 4ac over 2a. Yeah, that's what it is. And the a, b, and c, they refer to the terms a, term b, and term c. And what you do is you replace all the values of the terms in place of the letters a, b, and c. So we get x is equal to minus b, which is 7, so minus 7, plus or minus the square root of b squared is 7 squared, which is 49, and then minus 4 times a is minus 12. Minus 12 times minus 1 is plus 12. And underneath it's 2 times 3, which is 6. So 49 and 12 is 61. So you get x is equal to minus 7 plus or minus the square root of 61 over 6. Now this is where we split it into 2. So we get x is equal to minus 7 minus the square root of 61 over 6. And x is equal to minus 7 plus the square root of 61 over 6. And let's do that. The plus one is x is equal to 0.135, which to 2 decimal places is 0.14 to 2 decimal places. And this one, x is equal to minus 2.468, which to 2 decimal places is minus 2.5. Yeah, to 2 decimal places. And you'll get the clue in the question. They say solve to 2 decimal places. Yeah, and you know, because it says 2 decimal places, it's time to use the quadratic formula. And that's all there is to that one. Seek out other examples of that, but yeah.